Hi friends, today we are going to know about height of blades of a reaction turbine. Height of blades of a reaction turbine. Okay, we have already discussed that in a reaction turbine, the steam enters the moving blade, the whole circumference. As a result of this, the area through which the steam flow is always same. Now consider a reaction turbine. Okay, then here the blade ring is coming from D. This is H. Okay, now here I write down small d is equal to diameter of rotor drum. Now then here H, it represents height of blade, and V51 is equal to velocity of flow at exist. Okay, so therefore total area available for the same to flow. So A is equal to pi into D plus small h into h. Okay, and volume of steam flowing and volume of steam flowing is equal to pi into D plus h into Vf1. Okay, so we know that volume of 1 kg of steam at given pressure is Vg. We know that volume of 1 kg of steam at the given pressure is Vg. From steam tables. So therefore mass of steam flowing, so m is equal to pi into T plus h into h into Vf1 divided by Vg. Now this is kg per second. Now here, if the steam has a dryness fraction of x, then mass of steam flowing m is equal to pi into T plus h into h Vf1 divided by x into Vg. Okay, now then it's going to write pi dm h Vf1 divided by x into Vg. So this is kg per seconds. Where dm is the mean blade diameter and is equal to d plus h. Okay, so ఇక్కడ మనం గమనించాల్సింది ఏంటంటే, put it here, in most of the reaction turbines the velocity flow is constant, that is Vf is equal to Vf1. So therefore we can use the value of Vf instead of Vf1 in the above relation. ఇక్కడ మనం Vf బదులు Vf1 ని యూస్ చేస్తున్నాం అన్నమాట. ఓకే, and now we are going to solve problem for this. Okay, here is we have one problem. In a reaction turbine, the blade tips are inclined at 35 degrees and 20 degrees in direction of motion. The guide blades are of the same shape as the moving blades but reversed in direction at a certain place in the turbine. The drum diameter is 1 meter and the blades are 100 mm height. This place steam has a pressure of 1.7 bar and dryness 0.935. If the speed of the turbine is 250 rpm and the steam passes through the blades without shock, find the mass of steam flow and the power developed in the ring of the moving blades. Okay, this is the problem. Now I am going to solve this one. First I write down here data. So these all are given data. I'm going to write. Now D is given 1 meter, H is given 100 mm, that is equal to 0.1 meter. Now pressure is given bars and the dryness is given, alage speed is given. Okay, now we are going to draw the combined velocity diagram. Before going there, we know that blade speed, okay, VB. So we need to find VB. D plus H into N divided by 60. Now pi into 1 plus 0.1 into 250 divided by 60. So solve this thing, we will get the answer here, VB. So now once VB will come, I am going to draw here velocity diagram. A to B. Now I know with distance this is 14.4. Now I am going to take 20 degrees. Now here is 35 degrees. Then similarly here also I am going 20 degrees. This is also 35 degrees. I put it here D. Now this is the point is E, this is VF, and now this is VR, this is V. Here is VR1, this is V1, and then this is F. Okay, you know very well the distances in here to here. VW plus VW1. Okay, this is the diagram, and by measurement from velocity triangle we find the change in the velocity of frill, EF, the distance. Okay, ఇది వెలాసిటీ ఎలా కనుక్కోవాలి, ఇంతకుముందు చాలా ప్రాబ్లమ్స్ మనం చూసాం. సో నేను ఇప్పుడు డైరెక్ట్గా దీన్ని రాస్తున్నాను. Why? Because we know very well how to solve this. By measurement from velocity triangle we find that change in the velocity of will. Okay, now here I put it VW plus VW1 is equal to VF, and the total is coming here meter per seconds, and velocity of flow at the outlet. So then here is equal to Vf1 is equal to df, that is equal to 10 meter per seconds. So this is the outlet Vf1. Okay, df, right? And now we are going to solve mass of steam flow. So mass of steam flow from steam tables, okay, corresponding to a pressure 1.7 bar, we find that specific volume of steam Vg is equal to 1.031 meter cube per kg. Okay, we take this value. So now we know mass of steam flow. We know mass of steam flow. M is equal to pi into d plus h into h Vf1 divided by x into Vg. Okay, now you know all values, you just substitute the values in here. 0.1 into 10 divided by 0.935 into 1.031. Okay, now calculate this, we get the answer here, kg per seconds. Okay, now we find M, mass of steam flow. Then we go to solve here power developed. So power developed in the ring of moving blades, we know that power developed in the ring of moving blades P is equal to M into VW plus VW1 into VB. So then 3.58 into 42.5 into 14.4. So then the value approximately it will come like this. So here is 2.191 kilowatt. This is the answer you will get. Okay, this is answer. And now here I substitute the VW1 is changing this value. Okay, here directly. Now VB already we find here 14.4. M is now only we find 3.58 kg per second. So substitute all values, we will get the power developed in the moving blades. And now going to see another problem. Okay, and a reaction turbine. So another problem is in here. A reaction turbine runs at 300 rpm. Reaction turbine runs at 300 rpm and its steam consumption is 15,400 kg per hour. Steam consumption is 15,400 kg per hour. The pressure of steam at a certain pair is 1.9 bar. Its dryness 0.93 and power developed by the pair is 3.5 kilowatt. The discharge blade tip angle is 20 degrees for both. Okay, fixed and moving blades. And the axial velocity of flow is 0.72 of the blade velocity ki flow velocity 0.72 ఉంటుంది. Okay, find the drum diameter and blade height. Take the tip leakage steam as 8%, but neglect blade thickness ni neglect చేయంటున్నాడు. Okay, right. So now we are going to see how to solve this one. Okay, solution given. Okay, then first one is given, n is given 300 rpm, and now here mass is given, m is equal to 15,400 kg per hour, but we need to change in these seconds to 8 kg per seconds. That is called, this is the divided by 3600. Okay, pressure is given 1.9 bar. Dryness fraction is also given. Dryness fraction is given 0.93. Yes. Okay, and power is given P 35 kilowatts, then 35 into 10 to the power of 3 watts. Now alpha is equal to 20 degrees, that is similar to pi also. Vf is equal to 0.72 VB. So this is given data. Okay, and here one point is there, since the tip leakage is 8%, so therefore actual mass of steam flowing over the blade, that is m is equal to 4.28 minus 4.28 into 0.08, so then that is equal to 3.94 kg per seconds. Okay, now here we need to know about first point is blade height. So blade height, so h is equal to blade height, and dm is equal to mean diameter of blades. Okay, so now we know that blade velocity, VB is equal to pi into dmn by 60. So pi into dm 300 divided by 60. So now solve this equation, we'll get here with relation of dm, so meter per second. So once we'll get VB, we are going to draw here compound velocity diagram. Okay, this is not given, VR V. This is not given. Then here is a 20 degrees. D. E. F. EF1. V1. AR1. EF. VW plus VW1. Okay, this is the diagram for this. And now let us draw the combined velocity triangle as shown in this. By measurement from velocity triangle we find the change in the velocity of wheel. I am going to write directly. We know very well how to find this. VW plus VW1 is equal to directly 46 dm meter per seconds. Okay, now we go for power developed. We know power developed formula. What is that? Here it will come P is equal to M into VW plus VW1 into VB. Then here 35 into 10 to cube is equal to M equal, so M is equal to also we know very well, so can put it. And now here this value 56 dm into 15.71 dm. Okay, so solve this thing. Here we could get dm sum. Okay, so the mean diameter is equal to 1.25 or dm is 1.11 meter. Okay, and vf1 is equal to vf. So then here 3 dm, so 1.3 into 1.11, that is equal to 12.54 meter per second. So then we go for stream tables. From stream tables, with pressure 1.9 bar, okay, the specific volume is taken as 0.929 meter cube per kg. Okay, now we know that mass of steam flow, that the thing is m. Mass of steam flow m, that is equal to m is equal to pi into dm into h into ef1 divided by x into vg. Okay, now I substitute these values in here. 3.94, 1 minute, yes, this is 3.94. okay, look at here, 3.94, m is equal to 3.94. I taken here 3.94, right? Okay, and dm is equal to 1.11, h is equal to we don't know, f is equal to 12.54 divided by drainage fraction is given, specific volume we taken from steam tables. So then here 50.6 h. So solve this thing. H is equal to 0.078 meters, that is called 78 mm. Okay, this is the procedure to find the height of the blade. Now we go for drum diameter. Now drum diameter we need to find here. We know D is equal to dm minus h, so that is equal to 1.11 minus 0.078. So calculate this, we'll get the answer 32 meter. Okay, this is the procedure to solve the diameter of the blade. Okay, right, this is the reaction turbines problems, and we will see some more problems in next class. Okay, thank you.